Communications Chester F. Carlson Award. Many of us, like me, have been her students, mastering neuroscience-backed tips on how to learn through her vastly popular blockbuster MOOC on Coursera, Learning How to Learn, that has today more than 3.5 million registered students globally. A distinguished military scholar and adventurer, Dr. Oakley has served as a U.S. Army captain, communications expert in Antarctica, and Russian translator on Soviet trawlers. She's a fellow of the Institute of Electrical and Electronic Engineers and the American Institute for Medical and Biological Engineering. Needless to say, it is an honor for me and for Coursera to host her today. In her talk, Dr. Oakley will delve into the transformative potential of generative AI in enhancing the ability to learn while detailing the essential cognitive processes involved in learning. She'll also cover why Gen AI literacy matters and should matter at all levels. Over to you, Dr. Oakley.
Okay, well, let's get right up here with share screen. So hopefully you can see my screen now.
Yes, we can.
Okay, great. I'm so glad to be here, and it's honor to represent Coursera's great learning adventures by helping you to see some of the productivity and learning aspects of generative AI that can really help you in your life. So we should begin by reviewing Fei Li's quote. And she is one of the preeminent researchers in AI. And she says AI won't replace humans, but humans who use AI will replace those who don't. So it's a revolutionary wave that's washing upon us. And you want to climb on board that wave. Otherwise, it can be a little bit, well, let us just say it will be very helpful for your career if you do. So I am from Oakland University, which is in Michigan. And so that's me going to work on a typical February day. But I teach this course, Learning How to Learn, with Terry Sanowski. And he is the Francis Crick Professor at the Salk Institute. So here's Terry going to work on a typical February day in San Diego. So well, he's actually taking a break at lunchtime, but that's one of the great things about online teaching is not only can students get together from anywhere in the world, but professors can get together from very different places as well. So to my shock, I was invited to speak at Harvard. I was kind of a nervous wreck because, it's Harvard. And I walked into the room and I was even more nervous because the room was packed, standing room only, all around the edges. And I thought, why are there so many people here? It turns out our one little course made for virtually nothing, mostly in my basement, had on the order of the same number of students as all of Harvard's massive open online courses and online courses put together, made for millions of dollars with hundreds of people. And this tells you that people around the world are starved for fresh, solid, scientifically based information about how their brain works so that they can learn more effectively and also be more productive. So Terry and I have done a lot of courses on Coursera, some great courses on teaching if you're a teacher, also on growing your career and breaking into doing things that you think you can't do. Also learning for youngsters. So take a look at those if you're interested. And the main thing that we want to to turn our attention to is, what does ChatGPT do? Now, a lot of you may know that what these large language models like ChatGPT do is they are trained somehow magically by predicting the next word in a sentence. So they do more than that, though. They know how to relate words within a sentence to one another. Now, this might seem like a sort of a trivial idea, but if you remember, about 5 years ago, if you went to Google Translate and asked it to translate, you know, it would, those sentences that it would translate would, there were tens if you've forgotten the beginning of it by the time you get to the end. But using some remarkable new techniques, large language models can relate not only all the words within a sentence, but they can relate them to, that sentence to the words in entire essays and indeed in entire broad swaths of the internet. How does this magic happen? If you look, I'm going to give you a teeny tiny history lesson. In 2017, a paper was published called Attention is All You Need. And this paper, Terry Sinowski, my co-instructor, was he was the president of the Neural Information Processing Society that published this paper at their conference. And he said, nobody thought this paper was any big deal. The reviewers, kind of relegated it off to a poster session. It was presented by a grad student. But it turns out that this paper presented an idea that was so important that this paper has now been cited over 100,000 times. And what this paper did was it introduced the idea of the transformer. And the transformer allows for really interesting things like this. If you look at, this is a new large language model fueled app called Suno. And with Suno, you can kind of coach it, give it a little prompt, and ask it to create a song about your prompt. So I prompted it to write a song about the research paper, Attention is All You Need. And next thing you know, I've got a really nice little song that go in loops, recurrent thoughts that go in loops. So it's all about transforms. I should say, if you have boyfriend, a girlfriend, a husband, a wife, your spouse, that you want to impress, just write a new song for them, and this will make it much easier. So this is a really new application that is far more creative than even the creators of transformers ever believed it could be. Now, what's at the heart of a transformer? What is it? I don't want to go into all the details, but what I do want to do is I just want to make you aware of the two essential parts of a transformer. One is the encoder, and that takes in your prompt, and it's processing it, as you'll see, in a very familiar way. I should point out, see this little positional encoding part? That's the magic right there. That's where a large embedding vector is created that makes a number that quantifies each word and its relationship to many, many other words. So we've got the encoder where we put our prompt into, and then we've got a decoder where the prompt or where the output comes out. So, we ask about a good restaurant that's near us in our city, and then it might spit out some information about a good restaurant. Of course, the nice thing about large language models is then you can refine it and say, yes, that's good, but I want a quiet restaurant, or I want a restaurant with dancing, or whatever you might want. And that's what makes it quite different than search engines. So you can converse with it. But from our aspect, what's really important about transformers is that the flow of information through that transformer is remarkably similar to the flow of information through the human brain. So this means if we understand just a little bit about how the brain works, we can actually understand how to use generative AI more effectively. So, let's look a little bit into the brain. If we know it's a very complex mechanism, but if we just focus in on its fundamental building block, at least one of them, it's the neuron. There's about 86 billion of them, plenty to spare. And these neurons have a few simple parts to them. They've got these sort of legs dangling out. Those are called dendrites. Got these dendritic spines, which are like toes coming off the legs. And then we've got an axon. It's like an arm that reaches out. And what neurons do is they like to reach out and send a signal to the next neuron. And what this is doing is making a connection when you are learning things. So when you are learning something, you are actually making connections between clusters of neurons. And this is in your long-term memory. If you don't make those connections in long-term memory, guess what? You actually have not learned the material. Unfortunately, educators and psychologists over the last few decades have said, oh, you don't need to remember things. You can always look things up. Would I be able to speak Spanish or Hindi or Japanese if I always just used Google Translate? Of course not. You need to have those connections that you've put into your long-term memory if you really want to be learning things. So this is important when it comes to things like ChatGPT, because it makes it so easy that you think you don't have to get it into your own mind how to do things like write an essay, write an email, research something. But you actually do need to have the fundamentals in your own mind. Otherwise, you cannot critically analyze some of the misleading results that you can get back from generative AI. So how do you strengthen those connections? You just practice. And through practice, you build strong, rich connections. If you don't practice, then your little synaptic janitor can sort of sweep those connections away. So this is why practicing, not by rereading, which is just, letting your eyes move over the page, and not by just underlining, which is, again, just letting your hand move over the page, but by retrieving the information from your own mind. Read a page and look away. See if you can remember the key ideas on those pages. But in any case, when you learn well, what you're doing is you're strengthening the connections between neurons. So you have this nice, rich set of links that you can easily pull to mind when you need them. Now, this brings me to something that's really important when it comes to learning something or telling someone else about a difficult to understand concept. And this is the value of metaphor. If you understand one concept, you can use that as a sort of bridge to more easily explain or understand a new concept. So let's say that when you were a little kid, you would play with water, you'd kind of mess around in puddles and so forth. And it took you quite a long time to figure out what the flow of water really means. What is current when it comes to water? But once you figure that idea of the flow of water and current, you can use that as a metaphor to explain about the flow of electrical current. So having a metaphor from something you already know to something you are learning can be invaluable. Now, when I was working on the book of Mind for Numbers, what I did was I reached out to thousands of top professors and teachers all around the world and asked them to review the manuscript, give me any suggestions and criticisms. And shocking percentages of these professors got back to me and gave me some great insights. One thing they said, though, that was really surprising for me was some of these really good teachers would say, the reason I'm a really good teacher is because I do this one little thing in my class, but I don't usually mention to my fellow professors that I do this because they make fun of me. So, what was that one little thing? It was the use of metaphor and analogy. And what this would do is these they would they would be able to teach much more easily some of these ideas. But if they told their fellow professors what they were doing, the other professors would say, "Oh, no wonder you're such a good teacher. You make it all easy for your students." But isn't that our job as a teacher, as a professor, to make it easier to understand? In fact, it's learning is a really hard thing to do. A recent meta-analysis came back and concluded, when looking at hundreds and hundreds of studies, guess what? Learning is really hard. And so anything we can do to make it a little bit easier can actually be a boon for you. So if you think about it, when you're looking at metaphors, a metaphor is, you can find a good one, but they always break down sooner or later. They're not appropriate. And so, like if you're using water to explain as a metaphor for electrical current flow, it works pretty well to start with, but at a quantum level, it breaks down. When it breaks down, you just get a new metaphor. So, just keep in mind, metaphors are just there for, to get you started, to bridge you into the new idea. So, how do you come up with metaphors? It used to be really difficult. You'd go to websites that collected metaphors. You'd read popular books, see if they had a metaphorical usage that helped you. But now you can just go to generative AI, go to one of those large language model platforms like Claude or ChatGPT or Gemini, and ask them for a metaphor, and it will really be helpful. So when you're struggling with a concept, so let's say that you are trying to understand the difference between main guard and scope in Python programming. Well, you can think of main guard as a gatekeeper to a castle, and scope as the rooms within the castle. And you can get a nice image that can help you. You can get some extra verbiage that really explains the metaphor. And so suddenly something that might have seemed really arcane and not graspable can become something that you can easily visualize and more easily think about. So more than that, when you're learning things, have you ever found that you really didn't want to learn something? like you had to learn something, but you hated the topic. There's a way around that, and that is to get a little bit of dopamine circulating in your brain. And dopamine helps, like when you figure out something you're curious about, it it like potentiates dopamine through the brain. And then that pathway where you figured out how to do something, it seals in that pathway of neurons. So dopamine can help enhance the building of those links. In fact, they find with little mice that get their dopamine systems inactivated, they can't learn anything new. So how do you get this dopamine going? Get yourself curious about what you're learning. If you dislike it, just tell it about yourself and then ask for some ideas about how you can get curious about things. So, for example, I was recently in Mongolia, and there I am on probably the world's ugliest, but sturdiest little Mongolian pony. And one thing that the professors there told me about was that they have a lot of students who come in off the Mongolian steppes. Now, these students really know things like herding, putting together a yurt, migratory patterns, stuff that professors don't know at all. But when these students come to the professors and want to learn about Python programming, they have nothing to connect it to. And they're really not, it's hard to get them enthusiastic about these new ideas. So that was a big problem they had. And what I mentioned was all you need to do is go to ChatGPT or one of the large language models and ask it for ideas. Tell it about the characteristics of your students and ask it for ideas about how to connect some of the topics you're teaching that they struggle with to something they already know. And in this example for Python programming, it gives a great way of understanding main guard and scope, for example, in terms of herding and enclosures, yurts and seasonal migrations, and so forth. So, if you are struggling with something, ask ChatGPT for some hints about how to provoke your own curiosity and how to connect it with something that you are interested in. And you'll be surprised at how it can help you become motivated. Now, one thing I want you to do is I want you to look at large language models like ChatGPT, like Claude, Gemini, all these different models. I'd like you to think of them as being like car engines. So if you learn to drive a car with one engine and then somebody swaps it out with a different engine, the driving of the car is really pretty much still the same. And it's like that with these large language models. If you learn to drive with one model, you can pretty much drive the other ones. Now, are there significant differences in how they might react to some of your prompts? Absolutely. So you do want to try the different platforms, try the different free versions, and you can be surprised sometimes. The reason I like Claude is because I can ask it for what are the key ideas of a research paper that I upload, and it will give me the key ideas. Whereas ChatGPT, it will just give me a summary, and that's quite different. But on the other hand, if I'm asking for an analysis of a spreadsheet and so forth, sometimes I find that ChatGPT does a better job with those kinds of things. So different models can have different things that they can be good at. Now, there's like at present, there's 7 international giants with large language models. So from the, kind of engines. In the West, we've got all the big companies that fund the different large language models. So these large language models, like ChatGPT, are really, really expensive to build. And so it's no surprise that a major company is usually affiliated with or backing a particular large language model. In the East, in China, there are also large language models, and they're pretty similar in size and scope to what we see in growing from Google, Amazon, and Microsoft and Meta. Now, one thing I want you to be aware of is something called the context window. And the context window is how many tokens it can take in at one time. And a token is just a little bit smaller than a word. So if you say that Claude can take in 200,000 tokens, that's maybe 150,000 words. But what this means is, what can you put in that it can analyze in one gulp? So it's sort of like how big is the gas tank in your car? How much gas can it guzzle? And this is important because sometimes you want it to look at a big piece of data to analyze it all at once. And I'll give you an example. So I wrote the book Uncommon Sense Teaching. And this book is it's all about teaching based on how the brain works. And the Japanese publisher asked me to write a foreword for that Japanese edition of the book. I don't know anything about teaching in Japan. So what I did was I was able to take my entire book, load it up on Claude, because it's less than like 150,000 words. And then I asked it, what does my book do that supports the general ways that Japanese teachers used to teach? And what ways does my book actually kind of fill in gaps that there are new insights from research that Japanese teachers don't generally use, but that this book could help inform them with? And I got great information back. And then when I got this information, I used that to help inform me as I was writing the foreword. I sent it off to my Japanese publisher, and whoop, she came back to me and said, "How do you know so much about Japanese teaching?" And I was just like, oh my good, no. But you can see how this is like having an assistant who knows your stuff or knows the material you're trying to learn and can give you nicely informed guidance. But as you'll see, this assistant is wonderful and extremely helpful and occasionally a little bit psychotic. So you do need to be just a bit careful. Now, in 2023, there were 149 foundational large language models released. So they're coming out all the time. Usually you need a lot of money to have a very good large language model. So the biggest ones, those that are backed by major companies, are often some of the ones doing the most innovative work. But sometimes companies are coming out of the blue. Like for the last couple of months, the French company Mistral is emerging and really being competitive against like ChatGPT. So what I'm showing here will invariably change even in the months to come. So what is a large language model? If we look at the brain, remember I had mentioned that we have sort of sets of links in long-term memory when we learn things. But what I didn't mention was there are two ways that those links can be laid in long-term memory. And I'm going to show you the two pathways, but don't worry, you don't need to remember, the name of the pathway. All you need to remember is the two pathways are a little different, and the resulting links have a little bit different characteristics. So one pathway takes information from working memory, you're conscious of it, in the prefrontal cortex. I like to model that with an octopus. Takes that information that is coming into your brain, it puts it through the hippocampus into long-term memory. But then you have another pathway, and that is the automatic pathway. So you have information that is going through the basal ganglia into long-term memory. And this different pathway, as it turns out, well, you need both types of links in order to be able to function effectively in the world. So if we take a little step back and look at a slightly different perspective at this, I'm going to put this declarative pathway as a blue box. So that's the one through the hippocampus. And the automatic pathway is this orange box. So if you think of your conscious working memory, what you're holding in mind, let's say that you're working a math problem. Your conscious working memory would like send a signal to your hippocampus and say, okay, let's step through and work logically through this math problem. And then you get the result. And it's a very logical sequence. And you're aware mostly of it. But now let's say that you are going to hit a ball, a baseball. So you have the bat in hand, and your brain tells yourself, you're actually telling sort of non-consciously your basal ganglia, but it tells yourself, hit the ball. So boom, you tell yourself to hit the ball, then you can see whether or not you hit the ball, but you have no idea how you actually learned to hit the ball. You don't know what was going on underneath that allowed you to hit or miss the ball. And what's going on underneath is this remarkable deep learning neural network. These circles are just neurons, and the lines in between them are just the connections between neurons. Now, this deep neural network is remarkably similar to the network that has been designed for large language models. Now, this is not to say that we don't have networks in the hippocampus, because we do, but we're really seeing how that the automatic system of the human brain through that basal ganglia is just so remarkably similar to what's going on with large language models. So you consciously tell yourself to hit a baseball, and then what's going on is, you try to hit the baseball, you get a value out, like I hit it, no, I didn't hit it. You try it again, and each time you hit the baseball, you're honing and refining all of those neural networks. You're strengthening some pathways, you're weakening other pathways, and you're refining that neural net, with a set of weights. In other words, the strength between the neurons, that ultimately that neural network can be trained so that you can hit the baseball really well. Now, this is often something affiliated with motor skills, but it's also mental skills, like being able to read a letter and parse letters so that you can put them together into words and so forth. And they find with those with dyslexia can often have challenges with this automatic system. And that's part of why they struggle to make that quick automatic ability to see what letters, to be able to make out a D as opposed to a B, for example. But as I mentioned, this non-conscious basal ganglia system is very much like what we see in large language models. And what's interesting from our perspective is we've got this non-conscious sort of large language model equivalent. And then we've got our conscious hippocampal system. But if you get damage to that hippocampal system, you can, like, my father had Alzheimer's. What Alzheimer's does is it destroys gradually the hippocampal system. So what would he do? He would make things up. He would confabulate things. It wasn't the way he was, when his brain was working perfectly, but he would just sort of hallucinate and make things up. And this is exactly what we see in large language models. They don't have that conscious deliberative system. They only have that automatic sort of system. And so they can hallucinate, they can make things up, and they don't have anything kind of like looking over them to say, oh, was this right? Was that wrong? Only you can do that. And only you can do that if you have knowledge in your long-term memory. So it is going to be really important as our kids are being educated to encourage them to be learning deeply, even though it's so easy to just, turn to ChatGPT. IQ scores rose around the world from the 1930s to the 1970s, and then they began falling from the 70s to today. So why did they rise? Well, researchers said it's because of education. Why is it falling? It implies it's something to do with education as well. What happened in 1970, or right in the 1970s? Calculators came out, and all of a sudden, educators started saying, you don't need to remember things. You can always just look things up. And so even within families, you can see that the older children are often smarter than the younger children on average. And so developing that brain power, using retrieval practice, remembering things is really important for learning things well and being able to critically analyze what generative AI is giving back as a result of our prompts. So just a quick overview of the whole ecosystem. If we look at Western engines, so to speak, here's some classics that are out there. Many of the apps and tools that have arisen from as a result of generative AI they've emerged from ChatGPT, because ChatGPT is like the first out of the gate. So if you look at writing assistants, for example, many of these are based off of the ChatGPT engine. Go and look at some of these, like Write Sonic is really quite interesting. You could take a research paper and turn it into a podcast or a blog post or all sorts of different things. Go play with some of these things. Also be aware, though, that sometimes, for example, Jasper has been in trouble lately because it is what is called a wrapper. In other words, it uses ChatGPT as its central engine that it works with, and it adds a little bit on top, but people are beginning to find that, hey, they can just go directly to ChatGPT and they don't have to pay a lot of money for Jasper. So you have to figure out, is it really value added on top of ChatGPT? I will say that in the world of research, there's a basket full of all sorts of different apps. I pay for an app called Scite, SCITE _. And this is, it's the way it works is it kind of checks itself. So it goes and finds research results as a consequence of my prompt, but then it has another part of itself that double checks whether the research it's found is real or confabulated. It's quite good. In fact, a lot of these research type apps have been trained more on research related documentation. For example, Semantic Scholar is based off of 200 million research papers. So it is really a very, very insightful in a way that ChatGPT itself, which is simply trained on the whole internet, which includes a lot of fluffy, not very important or relevant for good research stuff. It can put things forth in a much more solidly research-based way. There's live to internet apps like Copilot. Teachers and instructors can find some websites that are very good, like Magic School and so forth, EduAid. Creative productivity platforms like Canva and Gamma. There's coding that often grows out of Llama, the open source network. There's imagery, of course, like DALL-E, which comes from ChatGPT. And then from other sources, we've got things like Stable Diffusion, Dream Studio. Runway is emerging from Gemini. So there's lots of imagery options. For video, there's more and more coming out. So video is very difficult to do, but I think over the next couple of years, we're going to see some shocking advances. And even as it is, the advances that you can see are sometimes amazing. So this framework is based off a framework in Teaching with AI, the book, which I strongly recommend. It's by Bowen and Watson. And there's a few more books if you want to read and kind of get a better sense of what's going on in generative AI. My colleague Terry Sinowski has written ChatGPT and the Future of AI, wonderful book. Co-Intelligence by Ethan Mullick. These are all practical books, and they're really helpful for you in your day-to-day use of generative AI. For a little richer and deeper theoretical background, I recommend The Alignment Problem and Worlds I See. And then for sort of a worldwide overview, Kai-Fu Lee's book is an excellent start. Coursera has some fantastic courses on generative AI. I co-teach a new course that we're about to launch with Jules White, who has a plethora of great courses. One of his courses, Prompt Engineering for ChatGPT, is one of the top courses on Coursera, but many of them they're just excellent courses. Here is the new course that we'll be launching that Jules and I will be launching at the end of this month, Accelerate Your Learning with ChatGPT, which has way more than I have introduced in this one little introductory session. And we also there is also a new course that we'll be launching at the same time about critical thinking in the ChatGPT era. So I thank you so very much for your attention, and now we're ready for questions.
Thank you, Dr. Oakley. We do have lots of questions, and I'll start with one question which comes from a teacher who's talking about the balance between using generative AI for teaching and learning and human intervention. So the question is integrating AI into education more plausible and appropriate for mature students? I don't see how allowing beginner students, how it is going to help them. What is your take on this?
Oh, that's a really good question. Personally, my own sense is that you are right. Like if you have a 5-year-old child, you have to be a little careful about how much online exposure you want them to be having. And also, there's research evidence that young children need to have like that person that's directly interfacing with them. For example, if you're trying to teach a child a foreign language, they won't really get it very well from a screen. They won't even really pay attention necessarily, but they will pay attention to a person who's in front of them, grabbing their attention and talking with them. But when is the transition? That's a good question. I haven't seen research about it, but Jules White has an excellent course for parents about how to introduce the ideas of ChatGPT to your children. And his son even does a video on it. So I noticed Jules has a restriction of how much time his children are allowed to spend online. So I think if you balance it with making sure that they're not online too much, but use some of the ideas in Jules' wonderful course for parents and teachers about how to teach kids about generative AI. And I think that will really help you.
Thanks, Dr. Oakley. The next question, I'm going to combine 2 or 3 questions because they are coming specifically from teachers on what are the challenges that an educator might face while learning how to use generative AI in the teaching process, and how is AI going to impact teaching jobs?
So my sense is, I'll take the second question first. I think what generative AI is going to do, it in some sense makes your job harder because you've had the rug pulled out from under you. You can't give an essay for people to do or assign a bunch of homework and expect them to have to go off and think by themselves to learn the material, which kind of made it easy for us as teachers. It's like, okay, we're teaching this stuff, but you got to teach yourself as well when you're working on homework and things like that. All of a sudden, it's like, what? All these methods that we used are not available anymore. So, so that makes things harder. But by the same token, let's say that yeah, and we have, there's no easy solution for that. Nobody has waved a magic wand yet that says this is how we resolve this problem. The only way that most people can see to handle it is to test students when they are sitting there right in front of you to make sure that they do indeed have that knowledge inside their brains. But by the same token, let's say that you have a bunch of notes that you've developed over the years in teaching a class, but you want to have some kind of lesson plan formulated from that actually is in line with the latest teaching methods. Well, you can take a picture of your notes or just scan them in, and then ask it to read your notes and formulate a lesson plan in light of the insights in the book on common sense teaching, or pick your favorite teaching book, or in general for teaching methods. So you can get wonderful ideas. Like, you should always try to start your classes with a hook, something to get them curious. You can ask ChatGPT, how can I start with my class with a better hook? How can I get my students more curious? How can I motivate my students to want to learn this material themselves? And ChatGPT can give you some ideas there that can be incredibly helpful. So there's, it's just like when the development of writing first happened. You would think your writing is so obviously beneficial that everybody would want it, but that was not the case. When writing was first invented, they had those cuneiform tablets and they're printing on them. Memory experts got really upset because they said, you're not going to develop the mind by using memory techniques. So every technology, good, it has good aspects and it can have problematic aspects. And it's no different for this new technology. And so we'll just have to kind of adapt. We are riding the edge of the wave, so we don't know the answers to some of these questions. We have to kind of be figuring it out. But it's an exciting time to be in teaching, because I think there's going to be some great, it kind of asks us to up our game, help our students become more motivated so they themselves want to learn the material instead of us forcing it down them.
That's right. That's right. One question, which is, the big elephant in the room when it comes to generative AI, is on academic integrity. And we've heard lots of questions on how we can ensure that there is authentic learning happening, not much cheating, not much copying, when we are encouraging students to use generative AI.
The only way I know of right now is you park them in front of you and you test them. That's the only way that I know of for sure. That is as foolproof as you can make it, given the fact that students are very creative and innovative when it comes to cheating, whether it's with AI or any other way of being tested on material. So, like I said, we're at the beginning of the wave. I wish I could wave a magic wand here in front of you and say there's an easy answer for this question, but we don't have one. Well, we do. We have one, and that is test them in front of you on anything that's important.
Right. You had mentioned this thing about calculator coming in and causing a slight decline in our ability to learn. A related question is, when we connect our professional learning with artificial intelligence, it may be effective, but will it impact our subconscious mind, as we might get addicted to these AI tools instead of using our own cognitive power?
People have asked this question in research, and the answer is they don't know for sure. But I will tell you, let me give you one example of something that you can use that will, even if there's an addiction, you can still force yourself to be using that addiction to fuel changing your brain. So if you look at what is the most efficient way to help students learn, mostly people, like good educators, will say, create a concept map, right? But that's not the most effective way to help people learn. It's actually retrieval practice or recall. Because when you're first learning something, you get these weak links. And then each time you retrieve or practice it, like you pull it, you have a key idea on a flashcard or something. You think flashcards, oh, that's for trivial facts. No, well, first off, you have to get facts in your brain to actually learn something. But if you want to start connecting things together, you want to be kind of thinking about it in your own mind, retrieving it. It's not just simple rote learning. And a way that can help you to do all this is, I'm going to show you one flashcard system, but there's a number of them. So this one that I like is called I Do Recall. And if you look, it's got groups here. So you can get your class to actually analyze, create flashcards that they can share together. Take a look and see how this plays out. Turn this out down a little bit. Let me, okay. So this is, so what you do with I Do Recall is you're going to load up like a PDF, for example, or some kind of electronic document. And then you put it in, and so it's loaded here. You can add a keyword, and then you've got your document loaded in. Then you can use this AI button right here. You can generate a bunch of retrieval practice questions for every page. So here's retrieval practice questions that are created by generative AI, just based on the document that you've put in. Or you can, like, if you think there's an important fact you want to remember, or kind of really think about, you can use the AI button again and just select it. It will create a flashcard that forces you to think about and remember key ideas that you want. Then you can test yourself using, so you can practice with whatever flashcards you've created. And remember, the flashcards can be at very high Bloom's taxonomy levels, and you can rate yourself on how well you're doing. And then you can, this kind of system and some others, you can also have like YouTube videos. You can create flashcards off the scripts of YouTube videos. You can analyze your statistics over time. It's really a wonderful system. And what this is doing is, if you like generative AI, use it to help you build your own cognitive skills. And some of these new apps are really helpful at that kind of thing.
Thanks, Dr. Oakley. We have time for one final question and no conversation on.
Wait. It's
Yeah.
me. It's me. Can you say that again?
I said we have time for one final question, and no conversation on GenAI is complete without talking about ethical considerations. So the last question is, how can we effectively and ethically use generative AI for research purposes, especially because we know that AI generates content based on patterns learned from vast data sets? So are we infringing on somebody else's copyrights? And what kind of recommendation would you give for researchers?
So infringing on copyrights is something that's been being wrestled out in the courts now. Every single major AI company has been sued for copyright infringement on some aspect or other of their training models. And the reality is, it's pretty hard to train without having all that data. So if you are super concerned about that, then don't use generative AI. I would say the majority of researchers are going to be informed by generative AI in any case. And so that means you will be in a lesser mode competitively. When I use generative AI, like, it can make me aware of research findings that no matter how careful I have been, that I've missed. And, it might have a name and some tags and so forth that I did not think to look at. So I think of generative AI like this. When I write a research paper, I may show it to my husband. I may show it to my colleagues. I show it to friends and so forth. And they'll all come back with, some good criticisms, maybe some suggestions. No, that sentence is really not comprehensible. You need to word it like this. I never put in a footnote that says, my hubby recommended that I reword my sentence in such a way like this. I mean, nobody does that. And I tend to think of generative AI as being kind of like a colleague that is looking over and informing what I'm doing. But every word that I write is perhaps informed by some of that, but I'm the one that's taking the responsibility. There was an airline company that was sued, a Canadian airline company, because they had a bot that gave an $800 refund erroneously to a client or to a customer, and the customer then they asked for the money back, and the customer sued, and ultimately the airline company was presumed to be responsible for whatever that bot did. And it's somewhat analogous for us as researchers. The words that we put out and we submit, we are responsible for. So you better make sure that every word you put in is what you want and not something, it can be informed by AI, but it's, you don't want to cut and paste, because you're heading for trouble if you do that.
Thank you, Dr. Oakley. We are on the hour, so we will have to bring this masterclass to an end. I think what we really understood from what you said are that Gen AI is quite an inevitable part of our lives today, but we have to be able to take advantage of it using some of the neuroscience backed tips that you shared with teachers and learners on using generative AI effectively to improve that process. And of course, using it responsibly as a thought partner, as a colleague, rather than seeing it as I'm working against it, I'm going to have to plug the holes. So it is going to be something which is here to stay and which is going to be a very, very integral part of teaching and learning. And we would, on behalf of everybody who's attended today and who's watching this on demand later on, thank you, Dr. Oakley, for sharing and having one of the most engaging virtual masterclasses I've ever been part of. Thank you so much. Thank you, everyone. Have a good day.